1.
Another one.
Three, two, 1.
Okay, thank you. Let me share my screen. So I will be introducing to all of you the statistical tools that are being used in the world of statistics. And we will start with, for tonight, we will start with the z-test. Ayaw. Yun. So there are several statistical tools used in statistics. I will enumerate later the statistical tools useful in every significance of this study that you want to partake. So our activity number 14 is all about the statistical tools. So what are the learning objectives? Actually, it has only one. Apply a variety of statistical tools to process and manage numerical data. So by the end of this chapter or this session, you are expected to apply a variety of statistical tools. But in this case, we will only discuss first the z-test. And I will give examples, and for your assessment that I will be uploading later, you will have only 3 items to answer. Ay, tatlo pala to. 3 learning objectives. The second one is the use the methods of linear regression and correlations to predict the value of a variable given certain conditions. And I will also show examples later. Recognize the importance of testing of hypotheses in making decisions. So hypothesis, plural. So meaning there are many hypotheses that we are going to give. And you will know later the steps in hypothesis testing. I will show you examples. I think 2 examples. So in review, statistics involves the collection, organization, summarization, presentation, and interpretation of data. It has 2 branches, the descriptive statistics and inferential statistics. So I will give the comparison later what are those 2. But in general, there are only 2 types or 2 branches of statistics, the descriptive statistics and inferential statistics. So descriptive statistics is the term given to the analysis of data that helps describe, show, or summarize data in a meaningful way. So when using descriptive statistics, it is useful to summarize a group of data using a combination of tabulated description. You knew this already when we have our presentation of data that is using tables. Graphical description, so that is using graphs and charts, and statistical commentary, that is a discussion of the results. Actually, these 3 are the 3 ways of presenting the data: by tabular, by graphical, and by narrative or textual presentation. So the branch that allows to make predictions, so meaning you want to predict. For example, we are conducting a study now, the four of us, Dr. Edsel Umali, Dr. Andy Soberano, Director Gilbert Octavio, and myself, regarding the predictors of success, the results of the institutional assessment as predictors of the performance in the board examination vis-a-vis the faculty performance. So what affects the board results will be the faculty performance. And that study is a sample of predictions or inference from the data, which is called inferential statistics. So with inferential statistics, it takes data from samples and make generalizations about a population. So we are going to conduct inferential statistics to predict what will happen in the future. Just like the SWS survey, the Pulse Asia survey, that is an inferential statistics because they are predicting the two major surveys from Pulse Asia and SWS are predicting already the results of the senatorial balls. So, and most likely, ang gagaling nun. Most likely, whatever in their survey, the results of their survey, 90 to 95%, that will be the winners in the senatorial balls. The margin of error of their statistics is only plus minus 2.31%. As the recent study they have produced, imagine they are only conducting it to 1,800 respondents. 1,800 respondents with margin of error of plus minus 2.31%. And yet, they can predict. That's the power of statistics. So for instance, you might stand in a mall and ask a sample of 100 people if they like shopping at SM. So that is also a sample. You could make a bar chart of yes or no answers. That would be a descriptive statistics because you are only giving a description of their answers, yes or no. Or you could use your research and inferential statistics to reason that around 75 to 80% of the population, all shoppers in all malls like shopping at SM. So if you only want a description or just a demographics about the answers, you can make a bar chart of yes or no because that is a nominal data and you can use a bar chart. And that is a sample of descriptive statistics. But if you want to give a reason that around 75 to 80% of the population of all shoppers in all malls like shopping at SM, that is a sample of inferential statistics. Testing the significance of the differences between two means, two standard deviations, two proportions, or two percentages are important areas of inferential statistics. So mostly, inferential statistics use the following: differences between two means, two standard deviations, two proportions, or two percentages. Comparison between two or more variables often arises in research or experiments and to be able to make valid conclusions regarding the results of the study, one has to apply an appropriate test statistic. So you cannot use t-test of dependent means if there are three variables because three variables will involve already analysis of variance. So only up to two. If there are more than three variables, then that is MANOVA na or multivariate analysis of variance. And I will I will give samples later on as we discuss, but for now, we will start with the basic. So this chapter deals with the discussion of the different test statistics that are commonly used in research studies under inferential statistics. So I will be only giving you the commonly used in research studies. I will not give you non-parametric statistics such as Kruskal-Wallis, Cronbach's alpha. So those are higher level of statistics. Actually, in my master's, that is a single subject, the non-parametric statistics, to solve for Kruskal-Wallis statistics, Cronbach's alpha. Actually, those are tools to help if a given examination, let's say for example, the examination of PL-MOON, the entrance examination of PL-MOON is a reliable one. You are going to use Cronbach's alpha. And if you want to know the validity, some may use the Kruskal-Wallis. And I will not discuss that because that is not a common usage in research studies, but we will only discuss those commonly used in research studies. So in the statistical tools, these are the following. You will use hypothesis testing, and the second one is correlation and regression analysis. The only difference of correlation and regression is actually if that is the time. If you want to predict the future, that is using regression. If you want to know what is happening now, that is correlation. And under correlation, there are two, the Pearson R or the Pearson product moment correlation and Spearman-Rho correlation. And the difference of the two is only the scales of measurement. If the scales or levels of measurement is ordinal, you will use Spearman-Rho. If the level or scale of measurement is other than ordinal, then you will use the Pearson product moment correlation. And we will discuss those in depth when we reach that topic. We will focus more on hypothesis testing. So in statistics, decision-making starts with a concern about a population regarding its characteristics denoted by parameter values. We might be interested in the population parameter like the mean or the proportion. So these are parameter values. If you want to study the mean, you may use if the available data permits. If you want to use proportions, you may also do proportions or percentages in other terms. Proportion is, for example, 5 out of 8 or 5:8. So that is a proportion. Some may use standard deviations. So depending on the given data or the available data. So for instance, you are deciding to put up a business selling cars. Your first course before spending money in business is to know which car sells the most these days, right? You are not going to invest if you will know already that your business will be closed soon. Of course, you are going to start a business if your business will boom in the future. So statistics is one way of using, of knowing whether your business of selling cars, just in this case, will become a boom or not. So before you open a business of selling Toyota, Mitsubishi, Hyundai, Honda, Nissan, or Suzuki, you need to gather information which among these get the most number of sales. And how many existing distributors of these cars are out there? There are so many, that is one factor already. Do you want to compete with them? So to answer these questions, you need to gather data. What type of data? And where will you get them? So you simply need to do a survey. So that is very important, that where do you need to gather the data? Are you going to only market here in NCR or the province or the entire Philippines? Are you going to conduct a survey, an interview, quantitative data, or qualitative data? So those are the questions that you should go, or that should be answered before you make a conclusion if you are really going to push through in selling cars. So these concerns can be addressed in a procedure in statistics called hypothesis testing. So a hypothesis is a conjecture or a statement which aims to explain certain phenomena in the real world. Many hypotheses, statistical or not, are products of man's curiosity. So the more curious you are, the higher level of statistics that you can delve into. So to seek for the answers to these questions, so he tries to find and present evidences, then tests the resulting hypotheses using statistical tools and analysis. In statistical analysis, the truth of which will be either accepted or rejected within a certain critical interval. So according to the study, there is already a fixed value that we are going to compare so that we will know if the hypothesis that we are going to create will be accepted or rejected. The hypothesis that is subjected to testing to determine whether its truth can be accepted or rejected is the null hypothesis by H sub O. So that is the null hypothesis, or H sub O. This hypothesis states that there is no significant relationship or no significant difference between two or more variables, or that one variable does not affect another variable, whether the two variables are both dependent, whether the two variables are both independent variables. So for as long as one variable does not affect the other variable, then it has no significant relationship or no significant difference, then we will accept the first hypothesis, which is the null hypothesis. In statistical research, the hypothesis should be written in null form. For example, suppose you want to know whether method A is not more effective than method B in teaching mathematics in the modern world. So let's say, for example, the first method is simply discussion, then take-home assignment or take-home quiz. The second method is activity-based. After the discussion, the teacher will give an activity. So those are the two sample methods in teaching mathematics in the modern world. You may conduct statistical or hypothesis testing to know whether the first is more effective than the second one, or the second is more effective than the first, or it has no relationship, meaning they are just the same if the teacher is employing both methods. So the null hypothesis for this study will be there is no significant difference between the effectiveness of method A and method B. So in null hypothesis, always state that there is no significant difference given the two variables. So the first variable is this method of teaching. The second variable is this method of teaching. As I have said earlier, the first one is by simply discussion, then take-home assignment, take-home quiz. The second one is discussion or activity-based. After the discussion, right away, the teacher will give the activity for the students to answer, on which by using statistics, you will know if there is a significant difference or not. Another type of hypothesis aside from the null hypothesis is the alternative hypothesis, denoted by H sub A. So that is H sub A. This is the hypothesis that challenges the null hypothesis. If your null hypothesis is there is no significant difference, then the alternative hypothesis is there is a significant difference. So the alternative hypothesis for the previous example can be there is a significant difference between the effectiveness of method A and method B, or method A is more effective than method B, or method A is less effective than method B, depending on whether the type of test is either one-tailed or two-tailed. And this will be discussed in the succeeding lessons. If you want to know just one-sided, you may use the one-tailed. Pag left-tail, pwedeng doon nakalink. Yan yung may sumasagot na sa inyo dati na skewed to the left and skewed to the right. Pag ginraph kasi yan, you can clearly see that it is skewed to the left or leaning to the left, or skewed to the right or leaning to the right. So that is two-tailed. That is one-tailed. If you want to know both ways, that is two-tailed. And this will be discussed as stated in the slide in the succeeding lessons. Next is the significance level. So to test the null hypothesis of no significance in the difference between two methods, in the previous example, one must set the level of significance first. So this is the probability of having a type 1 error and is denoted by the symbol alpha or infinite. So that is the symbol for the type 1 error. What is type 1 error? A type 1 error is the probability of accepting the alternative hypothesis when in fact the null hypothesis is true. So totoo yung null hypothesis, but we want to accept the alternative hypothesis. The probability of accepting the null hypothesis when in fact it is false is called a type 2 error. And that is another type. And it is denoted by the symbol beta. And the most common level of significance is 5% or 0.05. In the table, it is always 0.05, but in the description, you will tell that the significance level is 5%. But actually, in the table, it's 0.05. So that's the difference. If type 1 error, you will accept the alternative hypothesis when in fact the null hypothesis is true. The type 2 error is you will accept the null hypothesis when in fact it is false. So this is the decision making, the 4 possible outcomes in decision making, decisions about the null hypothesis, and what is the reality. So if the null hypothesis is true and you rejected it, that means you committed a type 1 error. If the reality, the null hypothesis is true and you accepted the null hypothesis, that is the correct decision. That means your decision is correct. If the null hypothesis is false and you rejected it, that means you made a correct decision. While the null hypothesis is false and you accepted the null hypothesis, that means you committed a type 2 error. So you based your decision making in this table. If the null hypothesis is true and accepted, or if it is false and rejected, the decision is correct. Siyempre, alam mong mali si null hypothesis and you rejected it, you made a correct decision. Alam mong tama si null hypothesis and you accepted it, you made a correct decision. But if the null hypothesis is true and reject, the decision is incorrect and this is a type 1 error. If the null hypothesis is false and you accepted it, the decision is still incorrect. And this is a type 2 error. For example, Sarah insists that she is 31 years old, when in fact, she is 35 years old. Diba? Yan yung tunay, 35 years old. Pero ini-insist ni Sarah na siya ay 31 years old. What error is Sarah committing? Ang hypothesis mo, your null hypothesis is Sarah is 31 years old. Pero ang tunay, she is 35 years old. So in this case, you have a false na ang iyong null hypothesis, pero ina-accept siya. And what error is Sarah committing? So Sarah is rejecting the truth. She is committing a type 1 error. Another example, a man plans to go hunting the Philippine monkey-eating eagle, believing that it is a proof of his mettle. What type of error is this? So another example, a man plans to go hunting the Philippine monkey-eating eagle, believing that it is a proof of his mettle. Sikat ka, bayani ka, magaling ka. Kapag nakapag-hunt ka ng Philippine monkey-eating eagle. What type of error is this? If the first one, Sarah is rejecting the truth, she is committing a type 1 error. For this case, this is a type 2 error. Hunting the Philippine eagle is prohibited by law. Thus, it is not a good sport. It is a type 2 error since hunting the Philippine monkey-eating eagle is against the law. The man may find himself in jail if he goes out of his way hunting endangered species. So meaning na dapat nire-reject niya pero inaccept pa rin. So in decisions that we make, we form conclusions. And these conclusions are the basis of our actions. But this is not always the case in statistics because we make decisions based on sample information. Yung kanina kasi, ano lang yun madaling makita yung fact or parang not a fact or just a hearsay. But if you are dealing with so many data, so many variables, that's the time that you will base your decisions based on the data. So the best that we can do is to control the probability with which an error occurs. This is the reason why we are assigning small probability values to each of them. So you will know later the values associated with our computation. If the computed value is less than or equal to, if the computed value is greater than or equal to, so that you will know when to reject or when to accept a certain null hypothesis or decision. So one-tailed and two-tailed tests. So there are two tests depending on the data given. So you may use one-tailed tests or two-tailed tests. So a test is called a one-tailed test if the rejection region lies on one extreme side of the distribution, and two-tailed if the rejection region is located on both ends of the distribution. So if you want to test only that your graph, imagine niyo laging ang gitna ay mean. Gitna ay laging mean. If you want to lean to the left, that is one-tailed. Left, one-tailed test. Kapag right, right, one-tailed test. But if you want to test both sides, that is two-tailed test. Normally, it is given in the problem. So this is what I'm talking about. This is the normal distribution. This one is a two-tailed test because there are two. Yan, nakikita niyo yung blue. So meaning the value is negative 1.96. So this is given. Negative 1.96. So less than negative 1.96, we will accept. Greater than 1.96, we will also accept. And this is the normal probability curve or normal distribution. If you want only to the left side of the distribution, so this is assuming that your this is 0.05 significance level as determined by this one, 0.025 plus 0.025, that is 0.05. Still, the significance level is 5%. Letter B, leaning to the left. So this is a one-tailed test. Left, still 0.05. You notice that the value decreased, negative 1.645. So that is also given in the table. Letter C, so this right area shaded, total area under the normal curve. So this is leaning to the right. And values greater than 1.645, that's the time that we can only accept the null hypothesis. In letter B, values, if the computed value is less than negative 1.645, that's the time that we will accept the null hypothesis. For letter A, if the computed value is less than negative 1.96 or it is greater than 1.96, we will accept the null hypothesis. So this, imagine the region of acceptance, only a few. So these are the steps in testing hypotheses. Questions first before we proceed. None. So we will proceed. So the following are the steps when testing the truth of a hypothesis. So the first one, you should formulate the null hypothesis. Denote it as H sub O and the alternative hypothesis as H sub A. So that is the first one. Formulate the null and alternative hypothesis, denoted by H sub O and H sub A. Next is set the desired level of significance or the alpha level. Do you want it 0.01 or that is 99% significance level, or you want it 0.05 or 95% significance level, depending on the researcher. But most likely, we will use the 95% level of significance. So there is a higher margin of error or a higher acceptance of the null hypothesis. Next is to determine the appropriate test statistic to be used in testing the null hypothesis. Are you going to use z-test? Are you going t-test? Are you going to use correlation, p-value, z-value, t-value, f-value? So depending on the statistics or the available data. And for our purpose of discussion, I will tell you already the test statistics to be used. The fourth one is to compute for the value of the test statistics to be used. So there is a formula given. I will give the formula for the z-test for tonight that our discussion. So only one test statistics so that you will not be confused with the other test statistics. Next is to compute for the degrees of freedom if the test statistics is allowing to compute for the degrees of freedom, because there are some test statistics which don't have degrees of freedom. And it is already given. And find the tabular value using the table of values for different tests from the appendix tables. I will be giving you the tables where you can find the values to compare. Next is to state the decision rule. If the computed value is less than the tabular value, we will accept the null hypothesis. If the computed value is greater than the tabular value, we will reject the null hypothesis. Lastly, last na ba to? State the decision rule. If the computed value is less than the tabular value, accept the null hypothesis. If the computed value is greater than the tabular value, reject the null hypothesis. Compare the computed value to the tabular value. Make a conclusion using the result of the comparison. So these are the steps. I will make a specific example later. And this is the formula for the degrees of freedom. The degree of freedom gives the number of pieces of independent information available for computing variability. So this is for computation of variability. We have measures of variation, how the data varies. So these are involving variances and standard deviations. So for any statistical tool used in testing hypotheses, the number of degrees of freedom required will vary depending on the size of the distribution. So it depends on the size of the distribution. The higher the distribution that you will have, the more your data will vary. So for a single group of population, the number of degrees of freedom is n minus 1, where n is the population. So for example, you only have a single group of population, and that is only one section. You are conducting a study about your section, your 3B section. So that means the total number of students in your section, let's say 56, minus 1, the degrees of freedom is 55. If you have two groups, the formula for the degrees of freedom is n1 or n sub 1 plus n sub 2 minus 2 for t-test and n minus 2 for Pearson R. And these statistics will be discussed later in this chapter. So I think the z-test, we don't have the degrees of freedom yet. And these are more applicable to t-test. So if the tests are concerning the means, one statistical tool that can be used is the z-test on the comparison between the population mean and the sample mean. So if you have a given sample versus the whole population, so that is z-test on the comparison between the population mean and the sample mean. We also have t-test on the comparison between the population mean and the sample mean. So that is different. Z-test is the first one, while the other one is the t-test. Another one is t-test concerning means of independent samples. So if you have independent variables, meaning that the variables can stand alone, we can use t-test concerning means of independent samples. There is also another statistical tool wherein t-test on the significance of the difference between two correlated means. Halimbawa, gusto mo i-correlate yung performance sa midterm exam tapos yung performance niya sa buong course. In our case, mathematical statistics for IT. So there are many statistical tools that can be used, and we will focus first on the first one that I have mentioned, the z-test. Meron pa, z-test on the significance of difference between two independent proportions. So that is also another statistical tool. Pwede ring t-test on the significance of difference between two correlated means. So if the population mean and the population standard deviation, ito yung mga symbol, mu, and this symbol, I think this is the raw symbol, are known, and mu will be compared to a sample mean x bar, use the formula below. So this is actually comparing z-test already. The population mean versus the sample mean. And if the population mean is given and the sample mean is given, you will use the formula below. So here is the formula z. So this is z-test. Concerning z-test first, as I have told earlier, we will first discuss the z-test. Z is equal to the difference of the sample mean x bar minus the mu or the population mean divided by its variance or the population standard deviation or the rho multiplied by the square root of n, where n is the number of sample. Mamaya gagamitin natin yan. Mukha lang mahirap tignan because of the notations, but actually this is only a skill of substituting the correct data given into the formula. Mukha lang siyang mahirap. Z is equal to x bar, sample mean minus the mu, population mean, divided by the rho, or the population standard deviation multiplied by the square root of n, where n is the number of sample. The tabular values of z can be obtained from the following table. So these are all constants. According to the study, these are the accepted table. So this summary table of critical values. If one-tailed test and 0.1 level of significance, 0.05 level of significance, 0.025 level of significance, and 0.01 level of significance. So that is plus minus 1.28 for one-tailed test, plus minus 1.645, plus minus 1.96, and plus minus 2.33. So these are all constants, hindi na nagbabago yan. If you are going to conduct a two-tailed test, if you are using a 0.1, this 0.1 is 90% level of significance, 0.05, 95% level of significance, 97.5 level of significance, and 99% level of significance. And these are the critical values that we are going to compare based on our computed values. Ayan yung pagko-compare natin. Ang ibig sabihin lang nito, kung ano yung masosolve natin dito, i-compare natin dito sa mga values na to. At isa lang yon. Given lagi iyon. And the decision rule is denoted by this one, reject the null hypothesis if the absolute value of z, so that is the computed value of z. Ibig sabihin nun, ito, we will reject the null hypothesis if the computed value of z, meaning absolute value, kung ano man daw ang computed value nito, itong z na to, if this is greater than or equal to the Z tabular. Ito naman yung tabular. Depende sa level of significance. And it is stated in the problem always. For example, so that you will have a grasp of what a hypothesis testing is. For example, a company which makes a battery-operated toy car claims that its products have a mean lifespan of 5 years with a standard deviation of 2 years. O, diba? Given, no? Mean lifespan of 5 years with a standard deviation of 2 years. Test the null hypothesis that mu is equal to 5 years against the alternative hypothesis that years if a random sample of 40 toy cars was tested and found to have a mean lifespan of only 3 years, use a 5% level of significance. So kita mo na kagad, a company which makes a battery-operated toy car claims that its products, so ito yung buong population. Kasi kiniklaim niya that all of its products have a mean lifespan. Yung battery daw talaga ng toy car na yon ay tatagal ng 5 years. Sinabi niya, population, this is the population mean, 5 years. Given a standard deviation, nagbabago-bago daw, pwedeng plus 2, pwede siyang minus 2. Pwedeng masira agad yung battery plus 2 years, minus 2 years, or tumagal pa yung battery plus 2 years. Ayun ang ibig sabihin ng standard deviation. With a standard deviation of 2 years. So this is your population standard deviation. Next, we will test the null hypothesis that mu is equal to 5 years against the alternative hypothesis that years if a random sample, ito given na si n is equal to 40, sample of 40 toy cars was tested and found to have a mean. So this is a sample mean of only 3 years. And it is stated that we will use a 5% level of significance. So here is the solution of the hypothesis testing. The first one is to formulate the null hypothesis. So to formulate the null hypothesis, or H sub O, the mean lifespan of battery-operated toy cars is 5 years. So that is mu is equal to 5. Totoo daw. Totoo na mas tumatagal yung mga yung lifespan talaga ng battery ng pinoproduce nilang toy cars ay 5 years. Next, alternative hypothesis, the mean lifespan of battery-operated toy cars is not 5 years. So meaning, mu is not equal to 5. So meaning, the population mean is not really 5 years. Pwedeng less than, pwedeng greater than. So that's the first in the hypothesis testing. Formulate the null and alternative hypothesis. Next, it is stated that we will use a level of significance 0.05. And we want it two-tailed because we do not know. We do not know yet kung less than 5 years ba siya or pwedeng mas tumagal pa sa 5 years. So pwede natin i-test parehas, left and the right. Left-tailed or right-tailed. So it will be two-tailed. Hindi natin alam kung tatagal ba yung battery less than 5 years or greater than 5 years. And it is stated in the problem that we will use 0.05. And it's our decision to use two-tailed to know whether mas matagal ba sa 5 o mas mababa sa 5 years. And the first statistics that we are going to use, as stated in the formula, we will use the z-test as the test statistic. Now, for the computation, given your sample mean, given yung kanina, 3 years daw, sa 40 toy cars, ang kiniklaim nila, population mean 5 years, ang number of sample is 40, standard deviation or the variance is 2 years. It is also given. So all you have to do is to substitute all of these in the formula. We will compute for the Z. Your X bar is 3, sinubstitute, minus the population mean 5, sinubstitute, divided by the standard deviation of 2 years, sinubstitute sa denominator, multiplied by the square root of n. That is the formula, and your n is 40. Using your calculators, 3 minus 5 divided by 2 multiplied by the square root of 40, you will have negative 6.32. So this is now our computed Z value. So we are not yet done because we will compare this with the tabular value. This is just the computed value. Our critical value, since it is two-tailed, as earlier illustrated, two-tailed, if Z is less than negative 1.96 and Z is greater than 1.96. So these are the critical values. Galing itong mga values na ito doon sa tinignan natin kanina. Babalik ko. Ito, dito yon 1.96. Nakita nyo, 0.05 daw ang ginamit, 0.05 at two-tailed tayo, kaya plus minus 1.96. 0.05, two-tailed siya, kaya plus minus 1.96 ang critical value. So that's how you take a look at the tabular value. Next is the decision rule. Our decision will lie, we will reject the null hypothesis if the computed Z value, the absolute value of the computed value is greater than or equal to the tabular value, which is 1.96. Hindi totoo yung kiniklaim nila na 5 years. Kapag ang na-compute natin na value ay greater than or equal to the tabular Z value. Since the computed absolute value, Z value, di ba, computation natin kanina, negative 6.32, we need the positive 1, kaya siya naka-absolute value, which is 6.32 is greater than the tabular value, which is 1.96. Therefore, we are going to reject the null hypothesis. Hence, there is a significant difference between the population and sample mean lifespan of battery-operated toy cars. So their claim of the toy cars operation, the battery of the toy cars that they are using is not accepted. So we have to reject it because according to the statistics used, we need to reject. There is a significant difference between the population and sample mean lifespan of battery-operated toy cars. Question, di ba mukhang madali lang? Kaya pa ba? Mukha lang mahirap yan. Justin, kaya pa?
Medyo magulo sir.
Mahirap lang sundan kasi yung values. Mas madali ito discuss talaga ng face-to-face. Either way, I will just upload this PowerPoint presentation so that you will have a reference. I will give another example. A manufacturer of bicycle tires has developed a new design which he claims has an average lifespan of 5 years with a standard deviation of 1.2 years. So a manufacturer of bicycle tires has developed a new design which he claims has an average lifespan of 5 years with a standard deviation of 1.2 years. So meaning, kiniklaim ni manufacturer na yung mga gulong daw ng kanyang binibentang bisikleta na dinevelop niya sa new design, population mean niya is 5 years. Population standard deviation niya is 1.2 years. So this is your mu, this is your rho. A dealer of the product claims that the average lifespan of 150 samples of the tires is only 3.5 years. Nakita nyo? 3.5 years. Test the difference of the population and sample means at 5% level of significance. So this is the sample mean. The sample mean is 3.5. The sample population is 150. So we are just going to insert all of these numbers in the formula. So here is the solution. We will claim that there is no significant difference between the population and sample mean of bicycle tires lifespan. So walang pinagkaiba raw yung sample mean at saka population mean of bicycle lifespan. So walang pinagkaiba raw si 5 years tsaka 3.5 years. Yung 5 years na total population at si 3.5 years with 150 samples, walang pinagkaiba. So there is no significant difference between the population and sample mean of bicycle tires. So this one is different. Kanina, kinompare natin siya sa 5 years lang, kaya natin ginawang two-tailed. So this one, the second, Justin,
Sir Clark, yung X bar po ba yung 3.5? Tapos yung mu po yung
yung mu
5
is
years?
the
Okay.
population. So HA, or the alternative hypothesis, there is a significant difference between the population and sample mean of bicycle tires lifespan. So meaning, yung population mean na kiniklaim nila na 5 years, so X, or the sample mean, is less than the population mean. So we will use the one-tailed or the left tail 0.05 because we will only compare the two means. Two means lang. Unlike the first one, kinumpare natin siya sa total population, the mu is equal to 5 years. The other one, the mu is not equal to 5 years. It is two-tailed because we do not know if it is greater than 5 years or less than 5 years. Here, it is left tail because this one, our claim is less than the sample mean is less than the population mean. Again, we will focus on the usage of the z-test as test statistic. So we will use z-test as test statistic. So computation, our claim, the manufacturer claims that 3.5 years in his sample, population mean is 5 years, sample population is 150, standard deviation or the population standard deviation is 1.2. So by substitution in the formula, this is given tong formula na to. So X bar is 3.5, ito, sinubstitute, minus the population mean, which is 5, sinubstitute, divided by the standard deviation, 1.2, substitute sa rho, times the square root of the sample mean, the sample population, which is 150. Sinabstitute. So that is equal to negative 15.31. If we are going to compute for this one using your calculator, 3.5 minus 5 divided by 1.2 times the square root of 150, that is equal to negative 15.31. And this is our computed Z value. Remember, whatever result in the formula, that is the computed Z value. And we are going to compare this in the tabular Z value. The critical value now is Z is less than negative 1.645 because this is a left tail and one-tailed lang daw. One-tailed ang ating hahanapin. Saan nakuha itong negative 1.645? Doon sa kaninang table na pinakita ko sa inyo. Negative 1.645. Left tail sa kaliwa, so negative siya. Next, decision rule, we will reject the HO if the absolute value of the computed Z value is greater than or equal to the absolute value of the tabular. So we are going to reject the null hypothesis if this value is less than or equal to the computed value. So since the computed Z value, which is 15.31, is greater than the Z tabular, which is 1.645, therefore, we are going to reject the null hypothesis. Hence, there is a significant difference between the population and sample mean of bicycle tires lifespan. So meaning, again, yung kiniklaim na naman niya ay hindi totoo. Na kahit new design pa yon, mas tatagal daw ng 5 years. So sinasabi niya yung mga bicycle tires. Question. Justin.
No need pa po sir yung graph, no?
No need to graph. No need to graph.
Okay po. Thank you po.
Just follow the steps in hypothesis testing and you will not be get wrong. You will be guided if you follow the steps in hypothesis testing. Wala na. Question. Justin.
Tas lagi din po bang given yung one tail, two tail?
One-tailed or two-tailed?
Yes po.
Kayo magde-decide nun. Depende.
Kami po.
Depende
Okay.
sa inyong binigay na null and alternative hypothesis. Tignan niyo yung kaibahan kanina ng null hypothesis. Sa first example natin, kinumpare natin mu or the population mean equal to 5 years. Yung isa naman, population mean is not equal to 5 years. Kaya siya naging two-tailed kasi hindi mo alam kung mas tatagal ba yung battery na yon sa 5 years o mas mababa sa 5 years. So depende sa HO and HA, sa null and alternative hypothesis. Our second example, why it is one-tailed, because the construction of the null hypothesis, we are comparing the two means. The population mean is not equal to the sample mean is not equal to the population mean. And our alternative hypothesis is the sample mean, kasi nga sinabi, di ba, sample mean daw ay 3.5 is less than 5 years. Pinapatotohanan niya na yung 3.5 years ay less than sa 5 years. At ayun nga ang lumabas, there is a significant difference based on the computation. Diba? Ang lumabas talaga, totoo nga, na 3.5 years lang tumatagal yung mga baterya. Ay, yung mga baterya, yung mga gulong. Kaya siya one-tailed. Left-tailed. Yes.
Sir, paano
Yes.
po kung dalawa po yung yung mu, tapos naka-skew pa rin po siya sa left?
Dalawa yung mu.
Apo, kino-compare po yung dalawang mu.
Dalawang population, imposibleng magkaroon ng dalawang population mean. Dalawang mu.
Parang
dalawang-
kino-compare lang po.
Laging isa ay yung population mu at yung isa ay sample, yung x.
Ay, yung comparison lang po pala. Less than
Oo.
equal. Pero naka-skew pa rin po sa left or right. One tail pa rin po
ito.
ba yan?
One-tailed pa rin yun. Basta if you are comparing the two, the sample mean or the population mean, then that is one-tailed. Kung ginawa mo siyang greater than, halimbawa, ang given mas malaki talaga, ang sample mean niya ay 7 years. Tapos ang population mean niya ay 5 years. So babaliktarin mo siya. 7 is greater than 5.
Okay po. Thank you po.
Basta ang first lagi, no significant difference. Ibig sabihin, equal lang yung sinasabi niya. Whether it's 3.5 years or 5 years, the quality of the tires are the same. Yun ang ibig sabihin. Quality of the tires. Any
Yes,
other
sir.
question?
Kami rin po magpo-formulate ng hypothesis null and
Yung hypothesis. I will give you a sample na sasagutan ninyo.
Okay. Thank you po.
Three items lang to. Grabe, word lang binubuksan ang tagal. Oh. A researcher used a developed problem-solving test to randomly select 50 grade 6 pupils. So meron ka na kagad na 50. In this sample, the sample mean is 80. The standard deviation S is 10. The population and the standard deviation of the population used in the standardization of the test were 75 and 15 respectively. So this is the 75 daw is the mean of the population, and this is 15 is the standard deviation of the population. This is the sample standard deviation and the sample mean. Use the 95% confidence level to answer the following questions. Does the sample mean differ significantly from the population mean? O, madali. Does the sample mean? O, dali na magbuo ng hypothesis. H sub O, no significant difference. The sample mean has no significant difference with the population mean. So that is X bar is equal to the mu. HA, or the alternative hypothesis, X bar is not equal, is not equal to the mu. Ibig sabihin, magkaiba daw. There is a significant difference between the sample mean and the population mean. Can it be said that the sample mean is above average? So depending on your computation. Makikita nyo yon sa computation. Number 2, the owner of a factory that sells a particular bottled fruit juice claims that the average capacity of their product is 250 ml. To test the claim, a consumer group gets a sample of 100 such bottles calculates the capacity of each bottle, and then finds the mean capacity to be 248 ml. Hindi totoo. The standard deviation is 5 ml. Is the claim true? So same. Ito, given na to. 250 is the population mean. Sample population is 100. Sample mean is 248. Standard deviation of the whole population is 5. You then construct the HO and HA. And the last, in a plant nursery, the owner thinks that the length of seedlings in a box sprayed with a new kind of fertilizer has an average height of 26 centimeters after 3 days and standard deviation of 10 centimeters. Imagine the application of statistics. One researcher randomly selected 80 such seedlings and calculated the mean height to be 20 centimeters. Pinapabulaanan na agad. Sa 80 samples niya raw, 20 lang naman talaga yung totoo. And the standard deviation was 10 centimeters. Will you conduct a one-tailed test or two-tailed test? Proceed with the test using alpha level of 0.05. Lahat 0.05. Normal yun na ginagamit, 0.05. Pag 99% kasi, leaning towards accepting the null hypothesis yun. Because the acceptance, the rejection region is very low. Question, 3 items only. Just follow the test, hypothesis testing. Tanong pa. None? Pag nakita na to, wala na. Last na yun. So if none, I will leave you with this quote. Without data, you're just another person with an opinion. So by W. Edwards Deming. Thank you and God bless us all. Dapat laging data-driven. Data-driven. That's statistics. We cannot make decisions if there are no numbers, no data. Pag walang numbers, why would you support? So that's why it's always data-driven. So kindly open your cameras for the concluding photo opportunity. Grabe, gutom na ako. Hanggang 8:30 pa. Ramila, you know the drill. Only 8 open their cameras.
Three, two, one.
Another one.
Three, two, one.
Okay, thank you. Class is dismissed.